Welcome to this tutorial where by the mercies of God, I'll be able to solve the 2024 GCE question paper. Without further ado, let us start with the tutorial. Question A1. One of the laboratory rules is written as, do not touch any chemical reagent in the laboratory until you are told to do so. Explain why this rule is important. The reason as to why this rule is important is because it helps to prevent accidents that may occur in the laboratory, because some chemicals are corrosive as well as poisonous in nature. Okay, so following this rule helps to prevent that. In presenting my answer for this question, I wrote it helps to prevent accidents because some chemicals may be poisonous and corrosive. Question 2. State any two state any other two laboratory safety rules. Alright. So here I wrote, number 1, we should wear protective clothing in the lab. And number 2, we should never eat or drink in the lab. If we were asked to find, if we asked another laboratory rule, we can say we should never hold bottles by the neck. Right here, we are only required to write 2 rules. Okay. B. Explain the importance for the rules you stated in A2. Okay, for the first rule, it ensures that there is protection of the skin and the eye from direct contact with chemicals, e.g. acids. Remember, I said that chemicals such as acids are corrosive in nature, and because they are corrosive in nature, they can cause hazardous effects such as skin burns. Okay, so you can get skin burns. However, if you wear protective clothing whilst performing your experiments in the laboratory, you are prevented from getting skin burns. Alright, so that's the reason why this rule is important. Right. Then for the second rule, which is never eat or drink in the lab, it is important because it helps to prevent ingestion of food or drinks contaminated by chemicals in the laboratory. Alright, okay. Alright, let's now go to question 2. Question 2, A. Substance X has melting and boiling points of 67 degrees Celsius and 281 degrees Celsius respectively. In what state of matter is substance X at Roman numeral 1, 283 degrees Celsius, and Roman numeral 2 at room temperature? Okay, so in answering this question, we should be mindful of these 2 decisive words, which are melting and boiling point. We know that by definition, melting point is just the fixed temperature at which a substance changes its state from solid to liquid. Okay, and here we are told that the melting point of substance X is 67 degrees Celsius. So this means that any temperature that is below 67 degrees Celsius, substance X exists in solid state. Okay. Alright. Then we have another word here, which is boiling point. We know that by definition, boiling point is the constant temperature at which a substance changes its state from liquid to gas. Okay, so here for substance X, we are told that its boiling point is 281 degrees Celsius, meaning that any temperature that is above 281 degrees Celsius, substance X will exist in gaseous state, and any temperature that is between 67 degrees Celsius and 283 degrees Celsius, substance X exists as a liquid. Okay, so for Roman numeral 2, for Roman numeral 1, at 283 degrees Celsius, because this temperature is above the boiling point of substance X, surely substance X should exist in gaseous state. Okay, then at room temperature. Remember, room temperature is basically a temperature of around 25 degrees Celsius. So this temperature is below the substance X melting point. Therefore, at this temperature, the substance exists as a solid. Alright. Question B. Describe the movement of particles of substance X at 283 degrees Celsius. Alright, we have already put across here that at 283 degrees Celsius, substance X is in gaseous state. If we were to diagrammatically represent this, it would be something like this. As we can observe, the 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 particles in gaseous state, the movement of particles in gaseous state is that they move about randomly in all directions. Okay, so the particles will move about randomly in all directions. That's how the particles move at 283 degrees Celsius. So here I wrote the particles move about randomly in all directions due to weak intermolecular forces of attraction. Right. Question 2. Arrangement of particles of substance X at room temperature. Here we have already established that at room temperature, substance X exists as a solid, and we know that in a solid state, the particles are closely packed to each other such that there is barely any space in between the particles. Okay, so here in presenting my answer, I wrote the particles are closely packed, leaving behind minimal space in between the particles due to strong intermolecular forces of attraction among the particles. Alright, okay. Let's go to question 3. Study the following diagram showing a piece of apparatus. Give the name of the apparatus and state its use. So this apparatus is a separating funnel. Here I wrote the name is the separating funnel. The use of a separating funnel is that it is used to separate liquids. However, we should not just say liquids, but be specific in the type of the liquid this funnel separates. Remember, we have two types of liquids. We have miscible liquids as well as immiscible liquids. Miscible liquids are those that mix uniformly with each other, whereas the immiscible liquids are those types of liquids that do not mix uniformly with each other. They create distinct layers, as for example, the liquids involving water and oil. Okay, so for a separating funnel, it is used to separate immiscible liquids. Alright. Question B. Study the following chromatogram which was produced during the chromatography of an unknown dye X and four known inks A, B, C, and D. Alright. Question 1. Which of the known inks has all of its component present in unknown dye X? Alright. So here, this question is very easy in that we should just observe which ink has its spots that are in close alignment with the dyes of with the spots of ink X. Okay, so as we can observe here, the ink that has all its spots in alignment with the spots of ink X is D. Therefore, here the answer is ink D. Alright. Question 2. Circle the soluble spot on the chromatogram that has the least RF value and explain your answer. Alright. Here we should mark this decisive word, which is soluble spot. Okay. So this would immediately prevent us from choosing this spot C, because this spot is insoluble. Alright. An insoluble spot is a spot that does not move any distance away from the baseline. So it barely moves. Okay. So therefore it is insoluble, and thus it can be the answer. So here we should um circle the soluble spot. So this soluble spot should surely be this one. Okay. The reason why this one is the answer is because it has traveled the least distance away from the baseline. Okay. If you compare with other spots such as this one, and that one, and that one, this spot here, the one that I have circled, has traveled the least distance. Okay, therefore it has the lowest RF value. Remember, RF is equal to the distance traveled by the spot over the distance traveled by the solvent front. Okay. Alright. So here I wrote that because the spot traveled the least distance in comparison to other soluble spots. Okay. Then question 4. The two elements, hydrogen and oxygen, both exist as diatomic elements. Right. And we should remember that diatomic elements are elements whose molecules are made of two atoms. So if we observe for oxygen and hydrogen, its molecules are made up of two atoms. Okay. Right. Question A. The dot and cross diagram and displayed structure for hydrogen are shown. Alright. Okay, I'm expecting. Alright. Question A1. The single covalent bond between the two atoms holds the atoms firmly because it is a strong electrostatic force. What particles attract each other electrostatically in such a bond? Remember, for an electrostatic force to exist, they need to be um, positive charges as well as negative charges. Okay, so the positive charges that constitutes this electrostatic force are the the positively charged protons that are found in the nucleus, whereas the negative charges are these shared pairs of electrons. So they're the ones that create this electrostatic force of attraction. Alright, so here I wrote it occurs between the nucleus and the shared pair of electrons. Why? Because the nucleus has protons that are positively charged. Okay, so these protons are able to electrostatically attract the electrons, thereby forming strong electrostatic force of attraction. Question 2. Why then is the boiling point of hydrogen extremely too low? The reason why the boiling point of hydrogen is extremely too low is because it has weak intermolecular forces of attraction. Okay, so here I wrote because the intermolecular forces of attraction in hydrogen molecules is very weak, hence little energy is needed to separate the molecules. That's why it has low boiling point. Okay, question B. Use the concepts of both B. Use the concepts of both valency electrons and valency to explain why there is a double bond in the molecule of oxygen. This is a 3 marks question, so this requires a bit of tedious work. Okay, to better understand how we will present our answer, we should have an in-depth understanding of these words that I have underlined: valency electrons and valency. Remember, the definition of valency electrons is very simple. Valency electrons are basically the electrons in the outermost energy level. So for oxygen, since its electronic configuration is 2,6, it has 6 electrons in its outermost energy level. Therefore, oxygen has 6 valency electrons. Okay, then the definition of valency. There are 2 ways we can define this, but they basically mean the same thing. Number 1, valency is the combining power of an element. So for oxygen, its combining power is 2. Okay, so meaning that oxygen has a valency of 2. The other way you can define valency is that it is the number of electrons an atom loses, gains, or shares in order to attain a stable electronic configuration. So for oxygen, for it to be stable, remember, oxygen will only be stable when it has 8 electrons in its outermost energy level. So to get to 8, oxygen needs to have 2 more electrons. So it needs to either share or gain these 2 electrons. Okay, therefore the valency of oxygen is 2, because 2 represents the number of electrons oxygen needs to share or gain to attain a stable electronic configuration. Alright, so I presented my answer to say both oxygen atoms have 6 valency electrons. To attain octet, okay, alright, don't be confused by this word here, octet. Octet basically means to have 8 electrons in the outermost energy level. Okay, alright, so to attain octet, meaning to have 8 electrons in the outermost energy level, they each require 2 electrons. Okay, thus valency of oxygen is 2, and as such the 2 oxygen atoms share 4 electrons, resulting in a double bond being formed. Okay, so if we were to diagrammatically represent this, what we'll have is something like this. Okay, so we'll have something like this. Let me write it here. Okay, so we'll have that in total there are 4 electrons that are shared, and we know that one bond consists of 2 electrons. Okay, so 2 electrons make one bond, therefore 4 electrons will make 2 bonds, and these 2 bonds are what we call the double bond. Okay, that's the reason why I presented my answer in this format. Question C. Write a balanced chemical equation for the reaction between the 2 gases. So here we should write the equation for the reaction between oxygen and hydrogen. Alright, so we'll have O2 plus hydrogen, okay, which is in gas, to form water. Water is in liquid. And here, to balance this equation, so we need 2 here and a 2 here. Alright. Question 5. It's on more concept and it's very interesting. Okay. Limestone is an impure form of calcium carbonate. The percentage of calcium carbonate in limestone is investigated as follows. 10.2 grams of limestone is added to excess 300 centimeter cube of 1.0 mole per dm cube of hydrochloric acid. Hydrochloric acid, the whole calcium carbonate in limestone reacted as the only reactant in the limestone according to the equation. Right. So meaning here that limestone was a limiting reactant and the hydrochloric acid was the excess reactant. Right. Then we have this statement. The remaining acid requires just 4 grams of sodium hydroxide for complete neutralization. Alright. Alright. Question A. Determine the number of moles of hydrochloric acid that had earlier reacted with calcium carbonate. So here we need to find the number of moles of HCl that were in this reaction here. So to do this, number one, we should have the total number of moles of hydrochloric acid. From this information here, we can calculate the total number of moles of hydrochloric acid. Alright, then we will subtract this from okay, so we'll subtract this from this number of moles here. Right, so it will be easier for us to have the number of moles of hydrochloric acid with this information. Then we just subtract it from the total in order to have the number of moles that were present in this reaction as provided for by the question. Right, so to do this, number one, let us find the total number of moles of hydrochloric acid. Remember, number of moles of HCl is equal to concentration times volume. Alright, the concentration of HCl is 1.0 mole per decimeter cube. Its volume, the volume should not be in centimeter cube, but rather it should be in decimeter cube. So to convert the volume from centimeter cube to decimeter cube, we basically divide it over 1,000. So this will give me 0.3 decimeter cube. So I replace here 0.3, meaning that the total number of moles of HCl is 0.3 moles. Alright, then now I refer to this information provided by this statement here. Okay, alright, so here it says the remaining acid just requires 4.0 grams of sodium hydroxide for complete neutralization. Alright, and as we can observe here, the mole ratio of sodium hydroxide to hydrochloric acid is 1:1, meaning that the number of moles of sodium hydroxide are equal to the number of moles of hydrochloric acid. So here I can write, let me erase this, number of moles of sodium hydroxide equal to number of moles of HCl. Alright, So then, how do I calculate the number of moles of NaOH? So here I just use the formula that says number of moles is equal to mass over molar mass. Alright, the mass of sodium hydroxide is 4 grams. The molar mass of sodium hydroxide is 40. Doing so gave me a value of 0.1 mole. This means that the number of moles of hydrochloric acid that were present in this reaction is 0.1. Therefore, if we say 0.3 minus 0.1, which is equal to 0.2 mole, it means that we have determined the number of moles of HCl that had earlier reacted with calcium carbonate. So here the answer is 0.2 moles. Alright, question B. Hence, calculate the percentage. Question B. Hence, calculate the percentage purity of calcium carbonate in limestone. Remember, percentage purity is given by mass of the pure substance. Alright, so mass of the pure substance over the total mass of the substance multiplied by 100%. Okay, so here right, so here we are given this statement 10.2 grams of limestone. So this means that this here is the total mass of the substance. So what we are remaining with to calculate the percentage purity is the mass of the pure substance, and we can easily get this, right? Okay, so here remember, in this reaction here we calculated that the number of moles of HCl were 0.2 moles. So with this information, we can as well find the number of moles of calcium carbonate in this reaction. Okay, so to do so, we'll basically do this. So we'll have calcium carbonate here as well as HCl. So the mole ratio, the stoichiometric coefficient, of calcium carbonate is 1. Here, so it's 1. The stoichiometric coefficient of hydrochloric acid is 2. Okay, then we have 0.2 moles of hydrochloric acid. So let's represent this with an X. Okay, so if we do the basic math here, we'll have that 2x is equal to 0.2 mole. Dividing the entire part with 2, we'll have a value of 0.1 mole. Okay, so this means that 0.1 mole is the number of moles of calcium carbonate, and we have this formula: mass is equal to molar mass multiplied by number of moles. So the molar mass of calcium carbonate is 100, and the number of moles we calculated it as 0.1, giving me a value of 10.0 grams. So this is the mass of the pure calcium carbonate. Alright, so percentage purity will now be equal to 10 over 10.2 multiplied by 100%. This will give me a value of 98%. Right. Question 6. Chlorine is a diatomic element found in group 7. What name is given to group 7 elements? So group 7 elements are called halogens. Okay, so the word halogens means salt makers. Alright. Okay. Question B. What is meant by diatomic elements? Alright, so here I wrote that these are elements whose molecules contain two atoms. For example, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine. Okay, the molecules contain two elements. Right. Question C. Complete the following table. Right. So we are required to write a physical state at RTP. Number 1 of chlorine. So the physical state of chlorine at RTP is that chlorine is a gas. Then for bromine, bromine is a liquid at RTP, and iodine is a solid at RTP. Now, if the question said colors, okay, colors at RTP would have that chlorine gas is green in color, bromine is reddish brown, okay, so it is reddish brown, and iodine is in, it is black. Okay, so if the question says colors, those would be the best answers. Alright, question 7. Alright, question 7. Aqueous copper 2 sulfate solution and molten lead 2 bromide can be electrolyzed. For the electrolysis of copper 2 sulfate, explain why color intensity of the electrolyte remains unchanged during the process if copper electrodes are used. So the reason why this is the case is basically what we have is that for the electrolysis process, they're using copper electrodes, and we know that copper electrodes are active electrodes, meaning that they participate in the electrolysis process. So what will happen is that when electricity, when there is a discharge of electricity from the power supply, our electrolyte, which is the copper sulfate, will decompose. So it will decompose to form Cu2 plus ions as well as SO4 2 minus ions. Okay, so these Cu2 plus ions will be discharged at the cathode, so they will go to the negative, electrode, and they will be discharged. Okay, so we should expect that the concentration of the copper 2 plus ions decreases. However, that's not the case, because what the anode does is that the anode dissolves. So when the anode dissolves, okay, it gives the solution the copper 2 plus ions. So it continuously does this, thereby ensuring that the overall concentration of the Cu2 plus ions is unchanged. And if the concentration of the Cu2 plus ions is unchanged, then surely the intensity of the color will not change at all. Right? So this is what I wrote. Because the anode constantly replaces the copper ions discharged at the cathode, thus the overall concentration of copper ions remains unchanged. Okay, so this is the reason why the intensity is not affected here. Okay, question 2. Write 2 observations you would make during the process if carbon electrodes are used other than fading away of the blue color. So here now the observation number 1 is that a pink metal is deposited on the cathode. Okay, copper. Remember, copper is pink. Okay, so it will be deposited at the cathode. It's an observation. For an observation, we should be mindful that we should only write observations that can be detected by our five senses. So what we can see, maybe smell, or even touch. Right. We should avoid saying statements like a gas is seen. You can't see a gas. Okay. Right. So the other observation is that bubbles of oxygen gas are seen on the anode. Right. So this is an observation. Okay. Question B. For the electrolysis of lead to bromide, explain why solid lead to bromide will not conduct electricity. Remember, electricity can only be conducted by two examples of charge carriers. Okay, so the two examples of charge carriers that we have are electrons, and ions. Okay, so there are other charge carriers, but for this syllabus we only have electrons and ions. But in the case of solid lead to bromide, these two examples of charge carriers are unavailable. Therefore, there will be no charge carriers that would conduct the electricity. That's the reason why solid lead to bromide does not conduct electricity. Okay, so in presenting my answer, I wrote that this is because in solid lead to bromide there are no mobile ions to carry charge. Since the ions are in fixed positions, they are what we call localized. Okay, so the ions are localized. Being localized means that they are ions. The ions are in fixed positions. Okay, for them to conduct electricity, the ions should be delocalized. Alright, but this is not the case. Okay, question 2. Construct the equation for the two electrode reactions. Okay, so the equation at the cathode. Remember, at the cathode we have a type of reaction called a reduction reaction. In such a reaction, a chemical species gains electrons. So it gains electrons. Alright. So for the electrolysis of lead to bromide, okay, if it is in molten state, what we'll have are the ions that we'll have are leads to plus ions as well as the bromine ions. Okay, so the lead to plus ions will be discharged at the cathode. So at the cathode, this lead to plus ion will gain 2 electrons. So we'll have a reaction like this. Okay, so alright, so here it was liquid, like this. Alright, then at the anode, we have a type of reaction called an oxidation reaction, meaning that a chemical species loses electrons. So the bromide ion will lose 2 electrons. Okay, so it would lose 2 electrons like this. Right. Question 8. It is on non-metals. Elena set up the following apparatus for preparation of a gas collected over water in the laboratory. Name the gas collected. Okay. Alright. So the gas that would be evolved when a metal, e.g. zinc, reacts with an acid is called hydrogen gas. Okay. So this gas is hydrogen gas. Construct a balanced chemical equation for the reaction of dilute sulfuric acid and zinc. Include state symbols. This is very simple indeed. Okay. So so H2SO4, it is in aqueous plus zinc. Since it's a metal, it is in solid state. So what we'll have is that the zinc displaces hydrogen to form zinc sulfate plus hydrogen gas. Okay, so the zinc sulfate is in aqueous solution and this reaction is balanced. Alright. Question C. Explain why the gas can be collected over water. Alright. So there are three reasons why hydrogen is able, why you can collect hydrogen over water. Number one, and this is the most important reason, hydrogen is less denser, than water. Okay, so that's the reason why hydrogen can be collected over water. And number two, hydrogen is insoluble in water. Alright, it is insoluble in water. And number three, hydrogen does not react with the water. Okay, with water. So these are the three reasons why collection over water is suitable for hydrogen gas. Okay. Alright. Question D. Describe a chemical test for the gas produced. Alright. So the chemical test here would be that when the gas is introduced to a lightened splint, it burns with a pop sound. Okay. So when you introduce this hydrogen gas to a lightened splint, this hydrogen gas will burn with a pop sound. So this is a clear confirmation of the presence of hydrogen gas. Alright, so that marks the end of section A. Let's dive to section B. Answer 3 questions from this section. Write your answers in the separate answer booklet provided. Study the following reaction scheme and answer the questions that follow. Alright. Question A. By means of a chemical formula, identify substance A, B, D, and F. Alright. As we can observe here, when magnesium carbonate reacts with hydrochloric acid, three products are formed. Okay, and we should keep this in mind. When a carbonate reacts with a dilute acid, we have three substances produced. Number one, we have water. Secondly, we have carbon dioxide, and thirdly, a salt is produced. Okay, so here this means that A, since it is in liquid state, it is water. Alright, H2O like this. Then B, since it is a solution, B is supposed to be a salt, and this is a sort of magnesium chloride, like that. Okay, then D. Okay, so we would observe here that when we add silver nitrate plus magnesium chloride, a white precipitate is formed. So this white precipitate is of silver chloride. Okay, alright. So this white PPT here is silver chloride. So D is silver chloride. Okay, then F here. Alright, so here solution E. Solution E, if you follow this chemical equation here, it is magnesium nitrate. Alright, when we add sodium hydroxide to magnesium nitrate, a white PPT of magnesium hydroxide is formed. Okay, so this means that F is magnesium hydroxide. Alright, question B. Construct a balanced equation including state symbols for the reaction that occurs when number 1, solution B is added to silver acidified silver nitrate solution. Alright, solution B here is magnesium chloride here. So magnesium chloride plus silver nitrate will give me silver chloride plus magnesium nitrate. Okay, we should remember that the silver chloride, since it is a precipitate, it is in solid state, and the magnesium nitrate is in aqueous solution. So here there is a 2 here. Okay, so there is a 2 here. Okay, then this one here is aqueous, and this is also aqueous. Let me write it properly. Alright, I think this one is better. So what we have is that magnesium chloride plus 2 moles of silver nitrate reacts to give us magnesium nitrate plus the precipitate of silver chloride, which is in solid state. Alright, so we have answered this part. The second part says solution E is this, is added to sodium hydroxide solution. Alright, for the second part of the question, the reaction is this. So what we have is that magnesium nitrate reacts with the sodium hydroxide solution, forming magnesium hydroxide, which is the white PPTF, plus sodium nitrate solution, which is the solution G. Okay, then C says construct an ionic equation for the reaction in B1. Alright, for an ionic equation, alright, let us first write the equation itself. Okay, so we should start by writing the equation itself. Okay, so what we have is that silver nitrate plus magnesium chloride. Okay, forming silver chloride plus magnesium nitrate, like this. Alright, so we have 2 here and 2 here. Okay, so when writing an ionic equation, the key step is that uh, the aqueous chemical substances should be split. So the aqueous chemical substances that we have are the silver nitrate, magnesium nitrate, as well as uh, magnesium chloride. Okay, so they will split. Okay, all right. So we have 2Ag plus 2NO3 minus here plus Mg2 plus right plus okay 2CO minus like this equal to, for the chemical substance that is in solid state or liquid state, it does not split. It is only the aqueous substances that should be split. So the silver chloride remains like this. Okay, then plus magnesium to plus here plus uh, 2NO3 minus like this. Okay, so in writing the net ionic equation, what we'll have is that the spectator ions will cancel out. Remember, the spectator ions are those ions that are present on both sides of the equation. So if we can observe, magnesium is a spectator ion as well as the nitrate. Okay, so the net ionic equation will now be 2Ag plus, okay, then plus plus 2Cl minus like this to form silver chloride. Okay, so this is in solid and this is in aqueous. So that's how you write the ionic equation. Okay, question B10. Iodine and chlorine react as shown in the diagram. The following table shows their bond energy values. Calculate the overall energy change EH for the reaction. Alright, remember the formula for energy change is that energy change is equal to energy change, which is a enthalpy change, is equal to the sum of the bonds broken minus the sum of the bonds formed. Alright, so here the bonds that are broken are these here, the ones on the reactant side, which are the iodine as well as the chlorine bonds. So they are broken in order to form this iodine chloride bond. Okay, so as a start, let us have the energy for bonds broken. Okay, so bonds broken is equal to iodine, which is okay. So let me first write this. Right, so we have iodine plus chlorine like this. Alright, so the iodine is equal to 151 plus the chlorine, which is equal to 242. So in total, I'm getting a value of 151 plus 242, 393 kg per mole. So this is the enthalpy change for the bonds broken. Alright, Okay, then the sum of enthalpy change for the bonds formed will equal to 2. Okay, all right. So the iodine to chlorine bond has an enthalpy of 208. Okay, so this is 416 in total. All right, so overall what we have is that AH is equal to 393 minus 416. Okay, minus 416. So this is giving me a value of minus 23 kilojoules per mole. Alright, so this was the overall energy change for the given reaction. Question B1. Draw an energy level diagram for this reaction. Label on your diagram the axis, activation energy, and AH. Okay, so for an energy profile diagram, you draw it like this. Okay, so you have your y-axis like that and your x-axis. Since the enthalpy change that we calculated was a negative value, this means that this type of a reaction is an exothermic reaction, and the profile of an exothermic reaction would look something like this. Okay, so down here we have reaction pathway, then up here we have the AH, okay, on the y-axis. So the AH in kilojoules per mole. Okay, all right. So we are told to label the activation energy. The activation energy is this part here. Okay, so that's where our activation energy is. The enthalpy change AH, we calculated it to be minus 23 kilojoules per mole. And on this part here, what we will need to write are the reactants. Okay, so then on this part here, we need to write the product, which is iodine chloride. Okay, so that's how the energy profile diagram will look like. Okay, question B2. On the axis in B1, sketch the energy profile diagram you would expect if a catalyst was used. Alright, remember the work of a catalyst is basically to lower the activation energy. Okay, so alright, so I said my activation energy is here. So if a catalyst is used, this activation energy will be lowered. Okay, so it would be lowered, so it would be somewhere here, it would decrease. Okay, so here, catalyzed reaction activation energy. Okay, question C. The reaction can be reversed to form iodine and chlorine from iodine chloride. Construct a chemical equation for the reverse reaction. Include AH in your calculation. So include enthalpy change in your reaction. Alright, so this is how the reaction would be. I've included the enthalpy change, and these have arrows. As you know, they represent that the reaction is reversible. Question B11. Study the diagram shown for protection of the underground steel oil pipeline. What name is given to this particular method of rust prevention? So this method is what we call sacrificial protection. Okay. All right. Okay. To briefly explain how the pipeline is prevented from rusting. Okay. Okay. So the pipeline is made up of steel. Okay, steel, and we know that steel constitutes mainly of iron. Okay, so we can confidently say that the pipeline is mainly made up of iron. So this pipeline here, it is connected to a zinc block, and we are saying that this particular method of rust prevention is called sacrificial protection. Okay, so here we are taught to briefly explain how the pipeline is prevented from rusting. Okay, so when what will happen here is that when the pipeline is exposed to environmental conditions such as water and oxygen, okay, instead of the iron being corroded, or rather, instead of the iron reacting with these environmental conditions, what will happen is that since zinc is more reactive than the iron, it would react in the place of iron. So zinc is the one that would be reacting with the environmental conditions such as water and oxygen. So as a result, zinc is the one that would be corroded, and the steel pipeline would be safe. Okay, so that's how sacrificial protection works. Okay, explain what would happen to the pipeline if copper blocks were attached to it instead of zinc. Okay, so here instead of zinc, suppose we use copper. Okay, so in such a situation, the pipeline would rust over time. Okay, so what do I mean? Remember, zinc, remember I said here that the pipeline is mainly made up of iron. Okay, so um, in explaining how the pipeline works, I said that zinc would react in the place of iron. This is because zinc is more reactive than the iron, so it would prevent the iron from rusting. However, in this case, if we use copper, we know that iron is more reactive than copper. So if this pipeline here is exposed to environmental conditions such as water and oxygen, what will happen is that the the iron would react with these environmental conditions. Okay, so the copper would basically be doing nothing. Okay, so as a result, the iron would be rusting. Okay, so it would gradually rust over time. Okay, question B. Pure metals and alloys are diagrammatically represented differently. Draw diagrams representing copper. Okay, so for copper, say this is a pure metal. I can draw it like this. So this is copper. Then bronze. Bronze is a constituent of copper and tin. Okay, so copper and tin are the one that constitutes bronze. Okay, so drawing a diagram of the bronze structure, since bronze is an alloy and we know that an alloy is basically a mixture of two or more metals. So what we'll have is something like this. So we'll have different sized atoms, okay? And so here, these ones would be the atoms for tin, okay? And these ones here, the ones that are smaller, would be the atoms of copper. If you check from the periodic table, uh, uh, the tin has actually a larger atomic size than copper. So that's the reason why I've shown them to be like this. Okay, question C. State two advantages of using bronze rather than pure tin. Okay, number one advantage of using bronze is that it is harder than pure tin. So harder than pure tin. And the second advantage is that bronze is more resistant to corrosion, okay, than pure tin. So it is more resistant to corrosion than pure tin. Okay, let's answer this last question. The compound forms two functional group isomers A and B. Isomer A is a sweet smelling compound and neutral. Isomer B reacts with sodium carbonate, producing carbon dioxide. Okay, just from these two statements here, we can surely verify that isomer A is an ester and isomer B should be a carboxylic acid. Okay, it's a carboxylic acid. Okay, why? Because esters are sweet smelling compounds. Okay, so they are sweet smelling compounds. Then why B is an carboxylic acid is because when an acid reacts with a carbonate, it is the one that can produce carbon dioxide. Alright, then starting with the first question, it says explain why the two are functional group isomers. Okay, so they are functional group isomers because they have the same molecular formula. Okay, but they have different functional groups. Okay, A and B have different functional groups and yet they have the same molecular formula. That's the reason why they are called functional group isomers. And here, to have a better understanding, we should know what a functional group is. A functional group is basically an atom or group of atoms that denote the chemical properties of an organic compound. So, for example, for carboxylic acid, their functional group is this one. It's called a carboxyl functional group. So, for B. Then for A, if I'm not mistaken, it is shown like this. Okay. Right. It is an ester functional group. Alright. Question 2. Show the displayed full structures for A and B. Suggest their respective UPAC names. Alright. Alright. So we say that A is an ester and B is supposed to be a carboxylic acid. So carboxylic acid. Alright, so H4O2. The diagram that would be easier to draw is a carboxylic acid. So let's start with that. Alright, carboxylic acids, remember they have this general formula. Alright, so this general formula here, 2NCOOH, like this, where this N here basically represents the number of carbon atoms. Alright, so for the formula of B, it would be CH3COOH, like this. Alright, and in naming this carboxylic acid, since it has two carbon atoms, it starts with the prefix eth, and we know that all carboxylic acids have a name like this, so it would be ethanoic acid. Okay, so it is ethanoic acid, meaning that we are drawing the structure of ethanoic acid here. So ethanoic acid, COOH, like this. So ethanoic acid is drawn like this. Okay, H, H, and then H, like this. So, and ethanoic acid. So we are done with compound B. Then compound A, which is an ester. This one would be a little bit complicated, but not that complicated. Okay, all right, let me start from the roots. Esters are formed from a reaction between an acid and a carboxylic acid. So such a type of reaction is called an esterification reaction. Okay, so we should have an acid plus an alcohol that would react together to form an ester plus water. Water is also formed. Okay, all right. So from here we can give out we can establish the names of the acid, the carboxylic acid, as well as the alcohol that reacted. Okay, so since the overall number of carbon atoms are 2, meaning that each one, the carboxylic acid and the alcohol, will have one carbon atom. So the name of the carboxylic acid with one carbon atom is called methanoic acid. So we'll have methanoic acid reacting with the name of an alcohol with one carbon atom is called methanol. Right? We would have it reacting with methanol like this. So this would form an ester. Okay, and in giving the chemical formula of an ester, we start with the acid first. So the acid first. Okay, and here what we must note here is that since water is formed, remember water is H2O. Okay, so here what we have is that the carboxylic acid loses this hydroxide here, so it loses this hydroxide. Okay, so it will lose this hydroxide, and the alcohol loses this hydrogen. All right, so here what we'll end up having is this here, so they form water, and the name of this ester that is formed is called methyl methanoid. Right, methyl methanoid, methyl methanoid, like this. And uh, its formula is like this. Right, so a displayed structure would look something like this. So we have our H. Okay, so this is an H here, an H there, and an H here. So this here is how methyl methanoid is John. So I have succeeded in naming both A and B. Question 3. What is the name of the salt formed when isomer B reacts with sodium carbonate? Okay, so the name of the salt that would be formed, since we say that isomer B was ethanoic acid, would be sodium ethanoid. Okay, so that's the name of the salt. Alright, let's go to the B part of the question. Consider the reactions labeled 1 and 2 that produce ethanol. State the names of four reactions 1 and 2. So reaction 1, whereby glucose is converted to ethanol, is called fermentation. Alright. And reaction 2, whereby ethene is converted to ethanol, is called hydration reaction. Okay. Question B2. Give one difference between the conditions applied in the two reactions. So here we can say that for fermentation reaction, the condition that is applied is that a biological catalyst is used, whereas in a hydration reaction, a biological catalyst is not used. Okay, so that's one difference in the condition. And for fermentation, we should remember that the biological catalyst is from yeast and its name is zymase. Alright, give one commercial use of ethanol. So here we can say that ethanol is used in the production